Okay, this is 6.4, adding and subtracting binomials and trinomials. This is for pre-Cal 11. Kind of going along the last part of chapter 6. Whenever you're dealing with binomials in the denominator, we always want to either simplify it first or find a common denominator between the two. If the two of them already have the common denominator, you just subtract them like you normally would. So 3 over x plus 2 minus 5 over x plus 2, because they have the same denominator, you can just subtract them like you would be normally when it comes to fractional math. This goes to 3 minus 5 all over 6 plus 2. 3 minus 5, we get a final answer of negative 2 over x plus 2. Because we have a variable in your denominator, you also have to talk about your non-permissible values. Everything that x cannot be, in our case here, you'd go x plus 2 equals 0, and then you isolate for x. In our case, x cannot equal, not 2, 0. It should be negative 2. Like so. When they don't match, you got a couple of options. Usually they're going to be set up, if you can, to simplify one or both of them. So 3x plus 3 and 2x plus 2. I've got 2 divided by 3x plus 3 minus 5 over 2x plus 2. If you can, step 1 is always going to be to try and factor. And once you've done that, you're basically going to find a common factor. Once you've found the greatest common factor, you can kind of move on from there. So, 3x plus 3 and 2x plus 2, we can pull out a 3 out of the first and a 2 out of the second. So this is going to turn into 2 over 3 times x plus 1 minus 5 over 2 times x plus 1. We have to find our greatest common denominator, our greatest common factor between these two guys. And really it's boiling down to our 3 and 2, so we know that both of those, our greatest common factor would be 6x plus 1. So what do I do to each of these to get 6x plus 1? Well, for my first one, I'm going to multiply my top and bottom by 2, and my second one I'm going to multiply top and bottom by 3. So 2 times 2 turns into 4. It's actually 4 over 6x plus 1. And negative 5 turns into negative 15, and 2 times 3 is 6x plus 1. Now that they're the same denominators, we can basically subtract the 2, so it turns into 4 minus 15 all over 6x plus 1, and 4 minus 15 turns into negative 11 all over 6x plus 1. We still want to talk about the non-permissible values. What can x never be? And in our case here, we'd say x plus 1 equals 0. Therefore, x cannot equal negative 1. It gets a little trickier when you can no longer simplify. Now we have to do a little bit more math. So, kind of like we did beforehand, where if we had two fractions, you can cross multiply or multiply. So I know that the greatest common factor between x plus 2 and x minus 1 is going to be x plus 2 and times x minus 1. So you're basically going to multiply both sides by what is needed to get x plus 2, x minus 1. Left side I'm going to go times the top and bottom by x minus 1. Right side I'm going to multiply it by x plus 2. This turns into 3x times x minus 1 plus 4 times x plus 2, and each of these is over x minus 1 times x plus 2. You want to distribute each of these into your brackets, or sometimes called FOIL. So 3x times x is going to become 3x squared, and 3x times negative 1 becomes negative 3x. 4 times x turns into 4x, and 4 times 2 turns into positive 8. Now everything's been distributed, they're all over the same denominator, so I can combine the two. This will turn into 3x squared minus 3x plus 4x plus 8. Again, if this was a negative out front, that negative would have to be affecting each of the terms up top. It's a positive, so we don't have to worry about it. The very last step is to simplify. So there's no other squared terms, so I'm going to run out of room. I'm going to put it over here. We're going to have 3x squared. Negative 3x plus 4x turns into a positive x, and it's just positive 8 remaining. And I managed to pause the video by accident. Oops. This is all over top of x minus 1 and x plus 2. This is your final answer, and our non-permissible values are basically going to be when x minus 1 equals 0 and x plus 2 equals 0. So our restrictions are x cannot equal positive 1 or negative 2. Sometimes we're left with some trickier situations, in which case I would always recommend factoring or simplifying it first if you can. So when I first look at this, x squared minus 4 is really, we can use the perfect squared trinomial, basically square the first term, square the last term. There is no middle term, so now it's going to be x minus 2 times x plus 2. Subtract. The only thing I can really pull out of 2x minus x squared is I can pull out an x to leave me with 2 minus x. Please note that x minus 2 and 2 minus x are two different terms. But we can do a bit of a trick later on, or I guess we can do it right now, to sort of make life a little bit easier. My goal is to get these two terms to be the same to make simplifying later on a lot less stressful. When I have 2 minus x, I can pull out of that and factor out a negative 1. When I do that, I'm now left with a positive x, or really I'm left with negative 2 and positive x by pulling out a negative 1. If I then rearrange this, having still pulled out that negative 1, I'm left with x minus 2. These two are the same term. That and that are the same, which will make our life a lot easier later on. Because I've done that, when I rewrite this, this negative affects kind of the uppermost, or the numerator. And a negative 1 divided by a negative 1, they cancel each other out. If I pull out a negative 1 on my bottom, so this is now going to be basically negative 1 divided by x times negative 1 x minus 2. These two are going to cancel out, which means this now turns into 1 over x minus 2 times x plus 2. It's now adding, or positive, plus 1 over x times x minus 2. We can keep doing this and say, okay, we now have to find a common denominator between the two of these, and the only difference is this guy's missing an x and this guy's missing an x plus 2. So a common denominator is going to be x minus 2 times x plus 2 times x. So my left side, the only thing I'm really missing is I have to multiply top and bottom by x, and my right side I have to times top and bottom by x plus 2. I then will distribute that into each of those. I'm left with now x over top of x times x minus 2 times x plus 2, adding in x plus 2 over top of x times x minus 2 times x plus 2. They've got the same denominator, so we can now add the numerators, in which case it's basically going to be x plus an x. So this turns into 2x plus 2 all over x times x minus 2 times x plus 2. Now you could technically simplify this into 2 and x plus 1 for a slightly more correct answer, but leaving it like this. This isn't going to simplify anything down below, so I wouldn't really panic about that too much, but it is technically more correct to do this. Your non-permissible values, x cannot equal negative 2, positive 2, or 0. It's a lot of writing with these ones. The math isn't necessarily difficult, it's just there's a lot going on, and even I'm running out of space. I'd recommend as much space as you can, and try not to crowd your work. So for this one, I'm using an entire page because it looks not too bad, even though it's going to be a little miserable. So, trinomials on the bottom. The thing you want to do first is you have to factor each of these. And again, if you don't understand or you forget how to factor, go back and look at some of the videos from chapter, I believe it was chapter 3, where you need to know factoring from grade 10. It's huge right now. Basically, two things that will add up to your middle term and multiply to your last term. And this is going to take up a lot of room, so I'm going to try and write this as neat as I can, but also keeping space conscious. So two things that add to negative 1 multiply negative 12 is going to be negative 4 and positive 3. This is going to subtract 1, and two things that add up to negative 5 and add up to 16. Or not 16, add up to 6. That should be x minus 3 and x minus 2. You'll notice between all of these, there are no similarities, so unfortunately the common denominator is when you slap them all together. So it's going to be x minus 4 times x plus 3, x minus 3, and x minus 2. So for your left and right side, you're basically going to multiply by what is missing. So I'm going to multiply top and bottom over here by x minus 3 and x minus 2. I'm going to multiply my right side by x minus 4 and x plus 3. So now they should have the exact same denominators. Before we can do that, we're going to distribute out our numerator. So I've got 4 times x minus 3 times x minus 2. Oh, this is going to become a lot of writing real quick. In fact, I may just pause the video just so I don't burn up all this time writing. Okay. Now what you're going to do is you're basically going to multiply and FOIL these two guys out. So every term in the first multiplies every term. You're then also going to incorporate that 4. So x times x turns into x squared. X times negative 2 is negative 2x. Negative 3 times x is negative 3x. And negative 3 times negative 2 turns into positive 6. Now there's a 4 in front of all that. So what you're then going to do is also distribute that 4 into every single term. I'm not writing the denominator yet just because it'll take up more time. So 4 times x squared is 4x squared. 4 times negative 2x is negative 8x. 4 times negative 3 is negative 12x. And 4 times 6 should be positive 24. Positive. X times x is just x squared. X times positive 3 is positive 3x. Negative 4 times x is negative 4x. And negative 4 times negative 3 turns into negative 12. Now this negative in the front here, when we're going to combine these two, they're technically both over all that stuff down there. But because we're subtracting, when we're going to combine them into one long term, because now they do have the common denominator, that negative out front affects each of these terms. So, before we do anything else, 3x plus negative 4x turns into negative x. So I'm just going to not worry about that. However, now when I'm combining everything, there's a negative, essentially a negative 1, that's going to multiply every single term. So negative 1 times x squared turns into negative x squared. Negative 1 times negative x turns into positive x. And negative 1 times negative 12 turns into a positive 12. The very last step is to combine all like terms down below. We have two x squared terms. We got 4x squared minus x squared turns into positive 3x squared. We have negative 8x, negative 12x, and a positive x. So negative 8 plus negative 12 is negative 20, plus 1x turns into negative 19x. And we have positive 24 and positive 12 turns into positive 36. And this is all over top of x minus 3 times x minus 2, x minus 4 times x plus 3. And believe it or not, that is actually a final answer. So the math isn't any harder than what you did in grade 9 and grade 10. There's just a lot more of it, and if you don't slow down and distribute things properly, you're going to get lost. The last part of this is the non-permissible values. Basically, everything x cannot be in your denominator, in which case x cannot be positive 3, positive 2, positive 4, and negative 3. If you ever forget how we get those, you basically set 1, x minus 3, you set it equal to 0, and you're using algebra to isolate what would make x equal 0. And therefore it cannot be that number. That's it for those two. For this section at least. Your first question is you're going to add the following. We got 7 over x plus 1 plus 2x over top of x minus 8. And your second question will be tricky. Is 3 over x squared plus 6x plus 9 plus 7 over x squared plus 5x plus 6. If you have any questions or concerns,